CYOD. Now let me check. COD. Okay, 86.24. Now let me check. Yeah, 86.24. Now in my Excel it's 86.2. Okay, 86.2. 86.2. And BOD is 34.88. Now let me check. Yes, result is 34.7. in my Excel sheet. 34.7. It's similar with the tab. So let me test when I want to change the result. Now let me change. Okay, let me unlock, and now let me change the condition of the earn restraint. Okay, the parameter also important to define the C1, C2 and C3. Okay, C1, C2 and C3. Now let me change to pin support to pin. Okay, apply and run analysis and design again. Okay, click on steel frame design, start design check. Okay, now let me show the capacity ratio. Click on the design information, click apply. Now you see here the ratio is 1.89. Actually in my Excel sheet the result is only 1.27, but in Etabs is 1.89. And now let's jump and check the parameter again. You see here the station is 6. Yeah, at the support, and the design control, the pressure ratio is 1.89. Now click on the details and click on envelope scroll to zoom in. Now let me check again. You see here the parameter is C1 is not changed. It fit to 1.132. Yes, and the C2 and C3 is not changed. This parameter also very important. C1 for MCO. This parameter is very important to define the MCO. MCO is equal to C1 multiplied in other term, and C2 for LTD is very important. But Etabs is not change. The value is fit to the same, not change with the condition of the support. Okay, you see here the condition of support change, but this parameter is not change. And the LTD curve, yeah, curve A. Now let me check it correct. Curve A and alpha LTD is 0.21 is correct, and lambda LT is yes, is 0.4. Yes, is correct. And lambda LT yes, 1.4. Okay, and MCO is 32.29. You see here this value is 32.1. Okay, 32.1. You see here the MCO is not changed. Okay, the MCO is not changed. You see here because the parameter of C1 is not changed. And okay, now you know when you change. Now let me verify with the menu. Okay, click me to check. Let me check about the moment. Okay, the moment is 65.9. I round up to 66. Now let me jump it to pin. Okay, load apply at top. Okay, now let me check and change it to 66. Okay, now let's check for the shear force. Shear 22 is 44. Okay, 44 is the same. Here the design capacity ratio is 1.9. If you compare with the result in the Etabs, you can click on design display, and also the same is 1.9. This the problem right now. The tape is not change the value C1, C2 and C3. The value is very important to calculate the MCR and calculate for the LTD. Now let me check MCR. Yes, you see here it relates with other term and also with the C1. So when the value of C1 change, the MCR also change, also increase or decrease. And let me check for the C2. And the C2, where the C2 we use, let's click on the C2, click on the formula and click on the drag dependence. You see here also in terms of MCR drag. Oh yes, you see here. Now let me remove. Okay, we also multiply with C2. Okay, and let's draw torsional buckling. You can check with MB. Okay, yes. So this parameter very important, but the result in the tape will not change. This is the result when I compare with my set. It's the same. You can check. Okay, it's 1.9 and it tape is 1.9 also the same. And when we change the support assign, yes, assign join to fix and run analysis in design, and let me change the condition to fix. Okay, distributed load. Now also change fix distributed load and apply yes, destabilizing load and load apply at the top of the plank. Yeah, top of the beam, and the design ratio is 1.41. Yeah, the result in the tab is 1.26. Okay, let me check again. Stabilize load apply and the top. Okay, it's correct. And fix. Yes, fix distributed load. Fix distributed load. Okay, let me check. Fit distributed load is correct. Oh yes, you have to check about the MED. Okay, now let me check about MED. MED is 44. Okay, and VED is also 44. So the result, yes, the final result is around 94%. But in the Etabs, the result is so much different. The result is 1.26. It's over 100. So this beam cannot resist the applied load. Now let me jump to the software Graitec Advance Design. Okay, I show you in the about the load. Okay, now let me jump to check about the load. Okay, load for the light load and for the deload, and also check for the beam length is 6 meter, and the beam section is IPE 240, strength 235 megapascal. And after complete run analysis, okay, we apply the fixed support. And now let's check about the force. We check for the MY. Now let me put the MY. Yes, the moment is the same with the tape. Okay, and the shear force. Now let's check the shear force. Yes, it's the same. Now let's check for the stability. We have to check about the working ratio. Working ratio right now is maximum is 94%. Okay, let me check with the Excel set. It's correct. It's the same result. It's 0.94. It's 94%. It's correct. The result verify with the Graitec Advance Design and menu verify is the same. Okay, now let me check for the strength. Click on the map working ratio, and the strength is 51%. You can check here, 51%. And now let me check for the strength. Okay, yes, for the strength is 51%. It's the same. Okay, this one for the LTD. Yeah, for the LTD control is 0.94, and for the strength of the section, for the flexural and for the shear is 0.5. It less than 1 is okay. You see the relationship. It less than 1 is okay. So our result is the same with the Graitec Advance Design. Okay, let's click on the beam and click on shape sheet. Okay, to check about the cross section and to check about the cross section strength. You can check the cross section strength. The by OCD is 86.15. By OCD. Now let me check. Yes, CYOD is the value in Excel sheet is 86.2. Yes, in Graitec Advance Design is 86.15. Okay, let me check for the stability. We UKZ is equal 1 and KW is equal 1, C1 is equal 2.54 and C2 is equal 1.55. Now let me check the parameter is C1 is C2. Yes, C1 is 2.57 is correct with the Graitec Advance Design, and C2 is 1.55. Yes, might say is 1.56. Okay, and let's check with the CLT is equal to 0.54. Okay, now let me check CLT. Yes, it's the same. It's 0.54. And no, I don't have CY and CZ. So we check with the LTD. Yeah, it's the same. And the MCR is 62.11. Now let's check the MCR. Yeah, and this MCR in my say is 62.8. It's higher. Yeah, it's similar with the Graitec Advance Design. And MBOD is 46.88. BOD, yes, might say is 46.7. Okay, now it might say it no uncot. We do for the beam. Okay, and the ratio is 94%, and my ratio is also 94%. For the general approach, and for the equivalent weld section, the ratio is lower than the general approach. You see here the general approach is 0.94, and the weld section, equivalent weld section, is 0.83. It's 83%. Less than 1 is okay. Okay, now let me click come back. I want to change the support, and we will check together the parameter of beam or change or not, parameter C1 C2 change or not. Okay, let me click on this one and change the fit to other to make sure our structure, yes, stable. Okay, now come back. We keep everything the same, but we had to change the support condition. And let's check the steel design again. Run analysis and design. Okay, now let's check for the force, and by 66. Okay, now let me change my set. I change it to which to pin distributed load. Okay, this one is correct. Now let me change to pin distributed load. Okay, the design value is 1.27. okay, now let me check the stability working ratio. Now let me check 190%. What is different right now? What is different? Oh, you have to input MED again. Okay, now let me come back. 66. Okay, 66. And VED is 44. Okay, it's correct. So the design result is 1.9. Now let's check with Advance Design, stability and working ratio. Yes, the result is maximum is 190%. You can check here. Yeah, 190%. That is okay. Yes, the location is 190%. So with you on diagram, okay, you can display it home, display it at section. Okay, the result is 190%. Yeah, it similar, it's the same with my Excel sheet. Okay, the result in Graitec Advance Design in this the menu is the same. Okay, now let me check the parameter in Advance Design. Okay, click on the result, click on the save sheet. Yeah, cross section, deflection, cross section strength, by OD is 65.95. okay, the value in the graphic and the value MED is not the same. Now we have to change it to 65.95. okay, let me change 65. Yeah, it's the same. Yeah, 65, 66 is the same. And by COD is 86.15. yeah, the value is the same. Okay, is 86.2. Yeah, 86.15 in the chain. Now let's check the stability and design load case control. This beam is ultimate load combination, and SY is 6. Yeah, it's correct. For the buckling and for lateral torsional buckling, yeah, it correct. 6 meter. And the KZ is equal 1, KW is equal 1, C1 is equal to 1.13. Yeah, now let me check C1, the parameter of C1. The parameter of C1. Where is C1? Yes, this one. You see here the parameter is 1.13. Yes. Okay, the parameter is C1 is the same, and C2 is the same, and lambda LT is equal to 0.4. Yeah, it's correct. 0.4. And yeah, my Z don't have CY and CZ. Now let's check about the MCO. 32.18 MCO. Yes, 32.1. Yeah, it's the same. And MBOD 34.8. Now let me check MBOD 34.8. Yeah, my set is 34.7. It's similar, and the final ratio is 190%. Yes, it's the same. You see here the result in Graitec Advance Design. The parameter C1, C2, and C3 is change depend on the unrestrained condition. So the MCO also change. Yes, MCO also change. And you can verify it again, the MCO. But in Etabs software, this parameter is not changed, and the result you see here, the result we compare is not the same when we compare it the same case. Okay, now in the case I apply it pin support. You can change it again to assign the pin support and check the result. The result is not the same, it's different because Etabs do not update the parameter C1, C2, C3 and other parameter because I don't know what is error. You can test it with your software, with your CSI software, and compare it with my tutorial. It's the same or not? Yes, you can compare it, apply the same condition, support condition, and compare the result or analysis and design. The design ratio you can compare with my tutorial to make sure your product, CSI product, is the same with me or not. Okay. Yes. You see here, it's 1.9. Yes, it's 1.9. Okay. Yes, for the condition is okay. When you apply the uncondition is pin, the result is okay. But when you change the support condition to fit the parameter in the tab, do not change. This is the serious problem. You have to fix it. Yes, you can use other software in case you want to design in the zero code. I always verify it, check it to make sure this software can use with zero code or not, or you have to fix anything before you can continue to design this software for steel structure. I use for the concrete structure for steel structure you are the software. This is we can check together. You can verify with my tutorial and comment in my YouTube channel. I will check with your comment. Okay, now we complete design in Advanced Design. Now let's jump to the Dlubal Rfem. Okay, now let's check with the Dlubal Rfem. The result is 1.11. okay, now let me check 1.11 for the fit. Okay, for the fit. Now let me change to fit. Fit. Okay, it's okay. Now let me change to fit. Okay, and MED we also change. Now let me check for the steel static 44. Okay, now let me change to 44. Okay, you see here the result is 0.95, and the result in the Dlubal, the final result is 1.11. okay, 1.11. I think this result is similar, it's acceptable. Yeah, it's acceptable. We can check and what is different. Now let me check by clicking and design check the test. Okay, you see the MCO is equal to 45.25. now let me check. Okay, yes, my result is higher than the Dlubal Rfem, and the Dlubal Rfem do not use C1 for the MCO. It use alpha CO multiplied with by ED. You see here the value of alpha CO is equal 1.03, and finally the MCO equal to 45.25. yes, and so the other parameter will be changed. You see here the CLT bar, the include with the MCO. Yeah, MCO change, so the lambda LT bar also change. Yeah, other parameter also change, so we not fit with by itself. Okay, S is equal to 0.96. now let me check. Yeah, it's the same. This is a parameter defined for calculate the unrestrained KC. Okay, and the design is 1.11. okay, now let me change the unrestrained of the beam, and let's compare what is different. Seal. Yeah, let me seal it. Okay, wet. Okay, okay, we have to open this again. Dlubal Rfem, where is Dlubal Rfem? Okay, now let me open. during you open Dlubal Rfem, you have to connect with the internet, because this software need to access the license server. Okay, and click to the center. I want to open the existing project. Yes, existing project. Because the method in Dlubal Rfem use not the same with my Excel sheet, so it's difficult to verify each other. And now we try to change the support condition. Okay, you can click on support condition and node support, edit assign. Now let me change to hinge support, apply. Okay, and calculate all. Everything we keep it the same with my model. Just change the support condition, and we will check what is different when we change the support condition. Wow. Okay, now let me check for the design. Still design. Yes, error. You cannot design. Okay, it's singular. Yes. Now let me change in the design. Static, stability, static, load cache, design. Okay, edit. No, static analysis, edit. Okay, now let me check. No, let me check on the stability analysis, edit. Okay, now let's check on the calculate without loading for instability check mode shape. This one we also use the same. Click on apply, click OK. Now let's run analysis and design again. Here we call her the section if the software is not perform for the stability. Here the capacity is over too much, so the software will be alert the error, do not perform analysis and design. So we have to change the setting. Let's check it again. Okay. Wow. Yes, analysis type stability. Yes. Warning. Now let me check on design. No, can't design because not stable. Okay, now let me change the support condition to edit node support. We add new. And now let's check for the free files and click on apply. Okay. No, not VY, VH. Come back. Edit node. Yeah, VH, correct. Now let's calculate again. Okay, now our structure is stable. Okay, this is the very important condition. We have to make sure the boundary condition our structure is stable before we continue to analyze and design. This is the result of the moment is 65.72. Now let me check and okay, verify. 65.72 and check for the shear force, internal force. Reset is 43.8 and support condition is pin distributed. Yes, okay. Pin distributed. Okay, now let's change the ratio. Okay, to the steel design and design ratio on the member. Wow. 1. Yes, at the location is 1.48. Yes. Okay, and double click to check the design ratio. Now you can check the design stability lateral according to 6.3.2. Okay, the ED PWP LY SY. Okay, alpha C is equal, elastic critical moment is equal to 30 kilonewton met. Now let's check. Yes, it lower than my assessed. And yeah, vice and BOD only 28 and my assessed BOD is 34. It's difference. Yeah, it's difference. So the ratio cannot compare. Okay, it's over. My result is 1.9 and in the Dlubal is 2.2. Yeah, thank you for your watching. I hope you enjoyed the tutorial. You can make a model and compare each other with my tutorial, and I hope you can feedback and comment me what is different and what is the same. Thank you.